We'll be doing the miscellaneous or this worksheet today, which contains all the sums from miscellaneous. Uh, so let's start with the first one only 1 upon x minus x cube. So 1 upon x minus x cube to be integrated. I can do a simple thing here. I can write 1 upon, I take x common, we get 1 minus x square dx. Now, like some people prefer breaking it as 1 plus x, 1 minus x and apply partial fraction. But if I multiply the numerator and denominator by x, this will convert into a very simple sum, See? So, now I can take t equals to x square. So, dt will be equals to 2x dx. Now, your integral will change to half because of 2x dx. I have already a x here, so it will be dt upon t and 1 minus t. So again maybe partial fraction or open it up, but I still find doing this very nice trick, like t plus 1 minus t into 1 minus t. What's the advantage? T and t cancels to give you 1 back, which was the previous step, and we get half. But if I split, I'll get half 1 upon 1 minus t and plus half 1 upon t. And this will result in minus half log 1 minus t, minus because coefficient of t you have to divide by minus 1, and this is half log t plus c. So you can take half common and do t upon like half, and this is log t minus log 1 minus t. So can be written as log t upon 1 minus t plus c, put t back, and that's your answer. Fine. Yeah. Question number 2, rationalize. Multiply with root of x plus a minus of root of x plus b. So this will get squared and integrate. It's possible to individually integrate x plus a raised to the power half, etc. Fine. Third, the hint here is x equals to a by t. You can put 1 by t also. Put x as 1 by t or a by t and ask me if it is not coming in the class. Fourth, in this 3 by 4 has a great importance because the power is 3 by 4 now. So what we do is 1 upon x square, then see inside is x to the power 4 plus 1 raised to the power 3 by 4. So x to the power 4 plus 1 whole raised to the power 3 by 4 to be integrated. If you take, like, as the power is 3 by 4 upon 4, we have to take x to the power 4 common, even if it is not common sometimes. So this will become take x to the power 4, that is x to the power 4 out, and I am left with 1 plus 1 upon x to the power 4, and then the 3 by 4 power. I'll show you properly. So I write 3 by 4 here only. Now see what happens. This 3 by 4 will distribute to both. So you'll get 3 by 4 here multiplied gives you 1 upon x square into x cube, because 3 by 4 into 4. 4 into 3 by 4 is 3, and 1 plus 1 upon x to the power 4 raised to the power 3 by 4. This will become x to the power 5. So this thing changes to x to the power 5 here. You take t equals to 1 plus 1 upon x to the power 4. You'll see that dt is coming out to be minus 4 upon x to the power 5 dx. So see, you have x to the power 5, minus 4 is not there, I can create a minus 4 by multiplying and dividing. So this much, you understood I think, will become your dt. So dt upon t to the power 3 by 4 integrate. Fine. For fifth, take, because half and 1 by 3. Whenever you have this kind of question, 1 upon x to the power half and x to the power 1 by 3, take LCM of 2 and 3, that's 6. So x will be taken as t to the power 6. So basically in this sum we put x equals to t to the power 6, that's what even the hint is saying. Then carry on. Okay, you'll get a very simple sum, I'll show you. So this becomes, so you get dx upon, so let's not write dx, let's differentiate directly. So you get dx is equals to 6 t to the power 5 dt. So my question changes to 6 t to the power 5 dt upon t cube plus t square. So you can take 6 and t square is common, so we'll cancel to give you t cube upon t plus 1 dt. Now do plus 1 minus 1 on top and split. So make it this as one sum and this as another sum. So in this t cube plus 1, you can write t cube plus 1 as a q plus b cube. So becomes t plus 1, then t square minus t plus 1. Now you substitute this, your t plus 1 will cancel and you will be able to integrate this. Alright. Sixth, partial fraction of type 3. Because x square plus 9 you cannot factor into real linear factors. Okay. If suppose it is x square minus 9, we would have written x plus 3, x minus 3. Becomes partial fraction of type 1. But this is type 3. So you break it as I told you earlier. Fine. Break it as a upon x plus 1, b into 2x upon x square plus 9 plus c upon x square plus 9. Question number 7, take x minus a is equals to t and proceed. This is a very simple one. It's e to the power 5 log x is basically x to the power 5. E and log nullifies, so 5 goes to the power. So it's actually integration of x to the power 5 minus x to the power 4 upon x cube minus x square. So from this take x square common, from this take x to the power 4 common. Things will cancel to give you a very simple solution. Obviously sin x is equals to t. Okay, coming to question number 10th. So let's solve this 10th. Sin to the power 8x minus cos to the power 8x upon 1 minus 2 sin square x cos square x. So what we do, we break it as sin to the power 4x plus cos to the power 4x and this as sin to the power 4x minus cos to the power 4x. Okay. Making it sin to the power 4 whole square. So a square minus b square formula broke. And now in the denominator I am going to play a very nice trick here. 1 can be written as sin square x plus cos square x. Okay. And you'll say what's the trick here? So see, observe something. This is the commonly occurring mistake we make. And 2 sin square x cos square x. So it's like a plus b minus 2ab, not making any sense. But I'll take advantage of this thing to be 1. So I'll write a square here on my own. See, now 1 square is same, But this has changed its format fully. What is this now? This is a plus b whole square minus 2ab. So if I open this up, I get sine to the power 4x plus cos to the power 4x plus 2 sine square x and minus 2 sine square x. They cancel. So what you get is sine to the power 4x plus cos to the power 4x. Let's break this other one also. So I can write this as sine square x minus cos square x into sine square x plus cos square x, making it a plus b, a minus b again, and denominator change to sine to the power 4x plus cos to the power 4x. Isn't it brilliant? Very nice sum. So this and this cancels. This is 1. So if I take a minus sign common, I'll get a cos square x minus sine square x. So what is that? That's minus integration of cos 2x dx. That's sine 2x. So the answer is minus sine 2x upon 2. So just follow the steps, pause the video and do it on your own. Next question is 11th. 1 upon cos x plus a cos x plus b. 1 upon cos x plus a cos x plus b. Huh? Now this is special, like it's a category, and I solve it using one of my method. What I say that like cos same thing, huh? So we have to balance, like I say S stands for same, like cos or sine, fine, sine also present. S stands for same, then S stands for sine. So what I mean is that you'll write a sine on top. Why sine? Because they are same. Huh? You'll understand once I write the steps. Write x plus a minus x plus b, huh? As if like it should be independent of x. So I subtracted these two angles. You subtract or add accordingly what is required. Now you see the numerator is sine x plus a minus x plus b is actually sine a minus b. So I balanced it. So everything is balanced now, and this is cos x plus a cos x plus b. Now open this with sine a minus b formula. Okay, so you'll see that things are cancelling out to give you tan or cot to be integrated, and then you can easily integrate that with the formula. Fine. In case it is sine cos combination, I'll balance by cos. That's why I say S for same, S for sine. 12th you do x to the power 4 is equals to t. 13th you take e to the power x equals to t. 14th you can do partial fraction by taking x square equals to y, but only for the purpose of partial fraction. Don't do 2x dx equals to dy because you don't have a 2x here. Getting me? But I can make it very simple by doing this, that I have x square plus 1, x square plus 4 so I'll use this technique of mine. I see that this minus this is independent of x. So write on top x square plus 4 minus x square plus 1. But if I open this, I get 3. So let's balance by 1 by 3. Now what? So if you split it, we'll get 2 sums, see? So everything melts and it converts into a very simple sum. No need of any partial fraction, no need of any x square as y or anything. You directly get the result. And you'll get full marks, no issues, because everything is correct mathematically. Then you apply the formula. Fine. So last few things. Again they tried to fool us. It's e to the power log sin x. So it's actually sin x only. Fine. So this is actually, this is not there. This is sin x rather. This is also x cube. So this is 16 sum is actually x cube upon x to the power 4 plus 1. And see, if you take x to the power 4 plus 1 as t, you will get 1 by 4 dt upon t, so log. You take f of ax plus b equals to t here and you will get the result automatically. And then comes 18th. So what we do in 18th? Divide here by sin x and multiply by sin. Fine. So this will go up as cosec square, isn't it? Because sin to the power 4 goes outside the root as sin square x and goes up as cosec square x. So you get cosec square x in the numerator. However, the denominator is still sin x plus alpha upon sin x. So see what will happen to that. Sin x plus alpha is sin x cos alpha plus cos x sin alpha, and then we have a sin x. So let's split that sin x with both. Fine. Open the formula sin a plus b and split with sin x. So what you get is, you get cos alpha plus sin alpha into cot x. So we'll take this whole thing as t. Take t equals to cos alpha plus sin alpha cot x. So if I differentiate this, I'll get dt equals to 0 because cos alpha is a constant, and cot is minus cosec square, so you get minus sin alpha, the constant kept outside as it is, cosec square x dx. So you see that you have this cosec square x already. So your integral will change to minus 1 upon sin alpha, and you get a dt upon root t, which is 2 root t. Put the value back and is done. 20th, very important sum. For 20th, you do what? Like, keep in mind that you have to remove the root from the numerator at any cost for all algebraic integrations. If it is carrying a root in the numerator, we try to remove the root by multiplying or something. So let's multiply with 1 minus root x. What will happen? You'll get 1 minus root x in the numerator. Denominator, you'll get 1 minus x, because 1 plus root x into 1 minus root x is 1 minus x, and there is a root, so the root comes here. So becomes two different sums. One is 1 minus x raised to the power minus half. Okay, 1 upon root 1 minus x is this to be integrated, and the other one is root x upon 1 minus x under root. But then what I taught you, that you have to remove the root from the numerator, so I multiply with root x again. And see, this converts into x upon under root of, so this much converts into x upon under root of x minus x square dx. Okay, so this is what? This is linear upon root quadratic. So apply the necessary conditions for that and it's done. Don't put root x as cos 2 theta. It's a horrible solution because it becomes too much and you get so many trigonometric quantities. It takes so much time also, and you have to reconvert at the end. You can't leave your things in like inverse format, so it becomes pretty lengthy. Better you follow this. Okay, this is by parts, e to the power x fx plus f dash x, and this finally is simply type 2, partial fraction of type 2. Fine. So this is what all these sums about, like.